Okay, this lecture is going to be a little bit of review from our matter lecture and an introduction to solutions and mixtures. So first of all, let's reiterate what a mixture is. A mixture is a combination of two or more materials, but that combination can be separated. So what can we mix? We can mix all solids, liquids, and gases. But for the most part, we only look at solid liquid mixtures. There's three possible types. You have solid solid. So sugar and sand would be one. So if I had a beaker of sugar and a beaker of sand and mixed them together, you could see the difference between the sugar and sand, but they'd still be mixed together. You can have solid liquid. This would be like salt and water, Kool-Aid and water. And then you can have liquid liquid. So like if I was to mix water and oil or food coloring and water, that is liquid liquid. Okay, do all things mix is the next question. Yes, any two substances can be mixed together. The degree to which the two substances, though, interact with each other will determine the mixture type, right? So we know oil and water don't mix, except for like right where they're touching. So that they don't like to interact with each other, so their ability to mix is much lower. If two substances do not mix well, we call the product a heterogeneous mixture. And heterogeneous mixtures consist of more than one phase, so we can see the different components. This is what we were talking about last week, where I said if you have a bowl of Lucky Charms, you know which piece is the marshmallow and which piece is the non-marshmallow, right? But they're mixed together, but you can ultimately separate them. So oil and water, that's one I already talked about. Okay, what about homogeneous mixtures? Homogeneous mixtures, as review, are two substances that mix well together in a single phase, and it's referred to as homogeneous mixture. So for an example here, if I have salt and I have water, one's a liquid, one is a solid. When I mix them together, you cannot see the solid of the salt anymore. We sometimes call this a solution. And the example that I just gave you was salt and water. Okay? So we have mixtures. One's homogeneous, one's heterogeneous. Homogeneous means the same. Heterogeneous means different. So what's a substance? A substance is a form of matter having its own unique properties, which you've already discussed. All matter can be classified as either a mixture or a substance. And a pure substance consists of only one kind of particle, right? So water is a pure substance. Salt is a pure substance. Diamond is a pure substance because it's just itself. A mixture contains more than one type of particle. So if I took salt and mixed it with water, then that's a mixture. So is 100% pure apple juice just a pure substance? The answer is no, because apple juice contains water particles, sugar particles, and flavor particles all mixed together. So let's summarize. Like we've already done before, mixtures, substances. Mixtures can be homogeneous or heterogeneous, and substances are pure substances. Okay, so cosmetologists' primary use of solutions. So let's talk about how you use these. So what type of solutions do you think you could use? Take a few seconds, and you can't really talk to somebody, but let's go ahead and pause the video and see if you can think of at least 5 solutions that you'd be dealing with. So there's 2 main parts to a solution. You have a solute and a solute dissolves in the solution, and it will be the smaller amount in the solution. And then you have the solvent. It does the dissolving, and it will be the larger amount in the solution. So if I'm thinking about my saltwater example, the solute is going to be the salt because it does the dissolving, and the solvent is going to be water because it dissolves the salt. One way that you can think about the difference between two of these, solute is smaller, has less letters than solvent, so solute can fit inside of solvent. So the solute dissolves in the solvent. So let's identify the solute in the solvent. Salt and water. I just gave you this example. Solute, salt, solvent, water. What about this one? Sweet tea. Go ahead and take a second. The solute is going to be the tea and the sugar, and the solvent is water. Oh, I'm starting to see a trend here. The solvent is most of the time water. Last one, nail polish remover. So in nail polish remover, we have acetone and water. The solute is the acetone and the solvent is water. So you'll notice that water is primarily the solvent in most of our solutions. Solutions can also be gases and solids, right? So you use hairspray on clients. You use dry shampoo on clients, maybe, things like that. Those types of things are gas solutions. But here are just some examples. You can kind of look through those to just sort of see solutions that we can come across in nature. Okay, one big thing that we need to talk about is like dissolves like, right? So we know that oil and water don't mix. The reason that they don't mix is because they have two different identities of a particle. So chemicals that have similar properties will dissolve in one another. So like salt and water dissolve, so they have similar properties. And then I asked, do you think oil and water have similar properties? Why or why not? And the answer to this is going to be no, they do not have similar properties. Why? Because they do not dissolve within each other. And that's it. Thank you.